Hi, Karthik. Can you just tell us really quickly who are you, what's your role, and who do you work for?
All right. Hi, Bart. I am Karthik Ramanathan, and I'm a co-founder and a co-CEO at Yugabyte, and that's the company name. And we are a company that builds a relational database for the cloud. So we're simplifying data in the cloud.
What are three emerging Kubernetes tools that you're keeping an eye on?
Yeah. So the fun thing about Kubernetes is there are about 300 tools that are important to put it together in order to make a functional solution. So if I'm just saying three, it probably doesn't mean that those three are the only important ones. But hey, here goes. So the three tools I'll talk about. The first one is about observability, that area. This is Prometheus and bonus Thanos. Those two. I think the second one is around how network traffic gets shaped. So this is things like Istio and Ingress, right? Like those kind of tools. And the third one are the most fundamental tools in Kubernetes itself, which are things like kubectl and Rancher and the operators, that the core fabric of how to use. So those are, I'd say, the top three tools that I think about, I follow quite a bit. As a bonus, I also track K3s, which is the edge-based deployment, lightweight Kubernetes. So, but anyway, but the top three I did tell you, but there's a lot more that are important.
While scaling their Jenkins platform on Kubernetes to 10,000 builds per week, one of our guests, Stefan, and his team found that there are limits to network, CPU, IO, disk space, or memory. As they hit them, they restricted usage and worked around it. What's your approach to managing constrained resources in a Kubernetes cluster?
I would give a triple mental construct, right? I think it's just important to think through that. So the first one is to think in principles of repeatable units, right? So instead of making one giant deployment where things get out of control, it's better to make, I wouldn't say tiny, but I'd say mid-sized to not super large deployments where everything is not restricted, and think in terms of those blueprints that are repeated, right? So that's number one, where you constrain the size and create more repeated units, but don't make the size so small that you have 1,000 or 10,000 units, and then that becomes unmanageable and causes a different set of problems. So that's number one. I think number two is to use the limits function in Kubernetes really intelligently. Software built on top of Kubernetes like cloud native architecture should inherently understand pressure, throttle back, when they're, under constraints, how do they change the behavior to protect what is the service that they want to give the users on top while being able to handle and surface out meaningful information. So pick, set decent limits and pick software that's architected for cloud native. That's kind of the difference between pre-cloud native and cloud native software. And the third thing would be to invest in the right kind of actionable observability. So when you run out of one of these resources, the real answer is really simple, right? You ran out of disk or network, right? But getting to that answer, oh my god, that can be really tough, because it's like all you see symptoms all over the place, and it's very tough to zero in. So it's important to have, and you can get overwhelmed. Too many metrics which doesn't tell you the story, too few metrics which doesn't capture the whole story. So you have to have all the metrics but also make sense of all of them really quickly. So you need to know what happens in these cases in your stack and be able to get to them. So those would be the three things that I would say. Think in terms of repeatable pods or units that you deploy. The second one would be use the software that are architected for these kind of deployments that understand native rate pressure throttle. And third, invest in observability that exposes these pressure points in a very clear manner rather than sifting through a lot of data or not having data.
While maintaining 900 nodes and a 15,000 pod cluster, one of our guests, Ferris, explained their transition from Prometheus to Thanos, and eventually their decision to adopt Victoria metrics for the metric stack. What's your experience in monitoring and managing large scale clusters?
Yeah, as you know, one of the top tools for me to look at is Prometheus and Thanos, and I am following Victoria metrics as well. I mean, ultimately, when you have large scale systems, right? Like, so we talked about the previous question, how do you manage a large scale deployment, right? So, one way or the other, whether you cut it up into many units of deployments or a single unit, ultimately you want to have a single pane of glass for the whole system, right? Like, you don't want to have many panes for each of those pods. You don't want to group them in arbitrary ways. You want to know, is there a problem? Where is the problem? Are things inefficient? If so, where? And so on and so forth. What is the utilization? You want to answer a handful of questions, right? So that means you need to bring all of these systems together Prometheus is fantastic as a software that's able to bring data together, but it's not very scalable. That's what we've found. And you need to set up an elaborate set of aggregators, push pull, how much of memory can you give it, so on and so forth, right? So Thanos is a project that helps you scale that out pretty well. So our experience with that has been pretty good. We use Thanos for our fully managed cloud, and we've been looking and keeping an eye on this in the system at large, just on the space at large, just to see what are the improvements, what can we adopt, so on and so forth. But what they're saying, what they're thinking about, it's actually spot on, right? That is a problem. That is actually one of the fundamental problems that hits you in these autonomous cloud native systems, because no data means you're blind and you cannot automate the operations. And the more you learn about the shape of data when you hit a problem, the easier it is to build remediation, detection, and auto resolution, right? And that's really the point, is to eliminate people having to run things when systems can do it, especially given the scale.
One of our guests, Hans, compared delivering software now to 20 years ago. He mentioned that while downtime was acceptable in the past, it isn't today. Hence, building platforms on top of Kubernetes requires more tooling than ever. Is it possible to keep tool sprawling at bay? What kind of tools are essential for building mission critical platforms?
Yeah, so I think this is a great question, and I think you can keep tools sprawl to at a bay to some extent in the Kubernetes world, right? And it's not really the question of is it a tool sprawl or not. It's a question of how Kubernetes is architected and the way the ecosystem has developed, right? It's a very extensible ecosystem where at its core, Kubernetes does a few things, and it gives a lot of hooks in order for people to add on to. And everyone takes one area of concern, kind of like I play the analogy of microservices in the software development world to tooling in the Kubernetes world. So there's a lot of these micro tools that come together to get your end-to-end thing done, right? So rather than think in terms of tools, I think it's better to think in terms of areas and tool stacks in those areas, right? Like I think that's probably a better way to think about the overall cake, right? So as you're looking at the whole thing, look at each layer or each area of concern. So, like for example, the most basic area of concern is like software as code, like how or sorry infrastructure as code. Like so, how do you deploy your infrastructure as code? Like that's one of the most basic areas, right? So here, there's a few different options, right? When you look at it in the world of tools, there's like 1,000 of them, right, that you can do. But ultimately, you need to think about what is right for your business service you're building, the technical needs and your organization, and the culture of your organization, right? So there could be, like for example, you might use Helm charts, you might use operators, you might use Terraform. You could use a lot of other things, right? But what you pick, or what one or two or three of these you pick, really depends on the needs you have. But that's one area, right? How do you make deployments cookie cutter? The reason this is important is because, like we said, you want to segment out your deployments and create many blueprints of them rather than having to put everything into a single deployment. So if you're doing it by hand, you're probably doing it wrong in the world of Kubernetes, right? So you're not in the in like I think the questions you asked are also really good, by the way. So in the previous questions case, you're not building the observability and the rollout right. Like it's not as easy to roll out, and it's not the CI/CD way. You need systems to keep flowing through and deploying and creating blue-green systems and so on. The second area is one of core availability, right? Like availability in my mind splits into two parts. There is a part about, how do you deal with failures? And there's a part about how do you deal with operations, right? Both require availability. So people often focus on failures and say like, hey, if this fails, I'll lose something. They often forget about the thing that makes them cause the system to take failures, which is they have to do upgrades in and out. That's one of the key requirements of CI/CD. So from that point of view, think about the stateless systems, like how do you do your applications, and stateful systems, your data, right? And that's kind of where we come in as a provider. On the stateful side, we make the relational database completely available, right? So architected for Kubernetes, right? The third thing to think about like is observability. How do you do all of these observability? How do you make sure that, we talked about how do you know if is there smoke and is there fire? Can you quickly detect it in the huge forest of your deployment, right? So observability becomes super critical. And the last thing I'd say is portability and open standards, extremely critical. This is why a lot of the Kubernetes-based systems tend to be open source as well, because they're adhering to an open standard. They can go and get deployed anywhere you want. Ultimately, that is the promise of Kubernetes and cloud native architecture. So this is another area where we take great efforts to make sure it is just Postgres that we're bringing to the table. It's a very standard API. So ultimately, on top of these core building blocks, we talked about, like, how do you do the infrastructure as code? How do you do resilience and uptime? How do you do your observability, and how do you do your standard open standards? Now let's put the next layer on top, right? You need to think about scalability, because cost efficiency and scalability. You don't want a gigantic cluster when until you need it. And if you don't need it anymore, you want to be able to take it back down, right? So systems that are horizontally scalable or transparently vertically scalable, I'd say you don't need to do any work in order to scale them. Those kind of designs will win out. And so, this is another place where we put in a lot of effort into the data side of it. So you can just scale in and out the cluster. And so think about this for every piece of the stack, observability included, which we talked about in one of the previous points, right? And the other part is also about resource utilization. So you want to be able to set the limits and give the right amount and move stuff around in order to bin pack all of these applications the best way. So it's kind of like, how many items can you fit inside a box? If you do it the wrong way, very few items will fit in. But if you kind of fit it in the right way, you can get a lot more in, right? So that's kind of like how a Kubernetes cluster is. It's like this big box where you're putting a lot of applications with different shapes and sizes, and you want to get as many items in as possible, right? That's kind of your cost ultimately, right? So I'd say these are some of the overall next layer of the cake. And then the last layer of the cake, I'd say, is now there's a lot of focus on AI, ML, auto learning systems, auto remediation, and all of that. And Kubernetes definitely helps enhance that, because in the world of AI, ML, all of the reactions are automatic, right? So you don't want to be doing remediations manually. You don't want to be doing the detections manually. You don't want that whole flywheel of how do you do better detection and better remediation to be broken, because you have to manually move data. So it all gets automated. So from that perspective, thinking through how you set up your overall tech stack, infrastructure stack, deployment stack to do AI ML. And this is another area we focus on as well for the data layer.
Kubernetes turned 10 years old this year. What do you expect in the next 10 years to come?
Great question. One I often think about. So I'd say a few things. Like Kubernetes, like we talked about, the very fact that, you had to ask the question about how many tools does it take for Kubernetes, and is it possible to reduce it? It means there's a little too many, right? So I think one of the things that'll happen to Kubernetes is an insane level of simplification. So I think we're going to see that a lot. So that's one that I'm rooting for, and I'm hoping, and at least I do start seeing, right? Like whether it is by virtue of reducing the number of tools or by virtue of creating tool stacks, right, where it becomes simple for people to take a stack of tools and roll them out, and they don't care what's inside, right? That's one. The second one I'd say is Kubernetes is cloud neutral, but it's not cloud neutral. It's not always cloud neutral. And this specifically comes up with the network architecture more than anything else. Like everything else is cloud neutral, but the network architecture often isn't, because Kubernetes runs like inside a cluster. It's got encapsulation as one of its very critical core design philosophies. And encapsulation is the opposite of extensibility. It makes it very difficult. It makes it very closed. And so sometimes when you think about cloud deployments, at least we see this a lot from the data perspective, data tends to be duplicated, replicated, or some parts of it stored across different regions geographically, or even different clouds on premise, all of the different locations. So multi-cloud, hybrid cloud, multi-region, these are becoming a reality with the applications of the future, right? And the rate at which we're seeing such applications get built, we're seeing a lot of them. It's actually accelerating. So Kubernetes has to somehow grow up and kind of evolve to supporting these kind of applications. It's got very few patterns from a data perspective, I can tell you, but I'm sure it's the same that any other application, even the app folks will tell you the same thing. It's very tough to get Kubernetes networking to work in these scenarios, right? And that's what makes it very cloud specific as well. Like if you go to GKE, well, there's some patterns to do multi-region. If you go to EKS or AKS, is completely different. And if you roll your own Kubernetes, well, that's yet another thing. And then there's like things like MCS, and then Istio, and then Envoy, and Ingress. There's so many different things, and it becomes an actual design it on the fly. It's not a cookie cutter thing. So I'm hugely interested in seeing this portion simplified, because that makes our lives easier too. Because people often ask us, and we have to tell them, look, if you're going beyond this, then you need to figure out, is it this or that or that? And then people are, okay, which one do I take? And so we have to now start working with them to really understand this, right? So I think that's another area. The third area I think will be obviously around, on-prem and off-prem. So I see a lot of repatriation as much as I see people moving to the cloud. It's not quite as much, but it is starting to increase the number of people moving back to on-prem. So being able to support the hybrid deployments and the private cloud deployments, I think that's another area of maturity. I think that's definitely going to happen, right? And obviously this includes all kinds of workloads, including your AI, ML, Gen AI, all of that stuff. So enhancing to include all of that.
And with that in mind, what's next for you?
With respect to the database, I think we're like, our mission is to make Postgres cloud native. So that's literally in a sentence. And when you peel that onion a little bit, it means keep everything in Postgres as it is. So don't remove any functionality and make it work in a cloud native environment, which means all of the things we talked about with respect to Kubernetes, right? Easy to deploy and redeploy, easy to make it resilient, easy to scale, easy to make it multi-region, observable, all of that stuff. So we are, I'd say, a good chunk of the way into that journey. Our customers and users are seeing a lot of value, but there's still a lot to be done. So we need to continue that journey. So that's number one. Number two, we're seeing a lot of requests for folks asking us to help modernize existing applications into cloud native, right? So this can be like, in two parts. One part is move my application and data both into Kubernetes. This can be another way where I want my application to move into Kubernetes. My data can live anywhere, but it should have the same properties as Kubernetes. I don't care where it lives. So we can be VMs or something, but help me either way, right? So I think we're seeing a lot of pull from that direction. And what we're building is a very, very exciting open source tool called Voyager, which helps you take a traditional application and automatically figure out how to modernize it and make it cloud native by figuring out your data, your query patterns, your IOPS, your access patterns, and so on, and suggest, hey, here's what you need to change, right? And the counterpart to that, so we're building that as a copilot, and we're building another copilot, which is also super interesting, which sits alongside your application and keeps looking at it and saying, why don't you just try and write it the way you know to write an application? It could be against a traditional database. And this copilot will sit down and always look at your access patterns and say, okay, look, this access pattern is not cloud native. It's actually a better way to do this is this other way of doing it, or this is an anti-pattern, but it doesn't happen so often. So maybe you're okay with it for now, but if this pattern increases, I'll let you know, and maybe you might have to refactor this portion of your app. So make that transformation simpler. And I think we're seeing it all the way from people asking from mainframes to traditional databases like Oracle and SQL Server and DB and so on, right? And even Postgres and MySQL. So that's a big piece for us. And the third piece is to innovate on the data side as it comes to Gen AI, because we're seeing a lot of ask on that side as well. So those would be the three top things I'd say.
Sounds like you're pretty busy. What's the best way for people to get in touch with you?
Well, with me, I'm fairly active on LinkedIn, somewhat active on Twitter. LinkedIn is more preferable. And, you can also join our community Slack. I'm fairly active there. There's we're over 10,000 on the community Slack, and it's a fairly busy channel. People asking all sorts of interesting questions and sharing use cases. So any of those ways, work.
Perfect. Karthik, thank you so much for your time and sharing your knowledge with us today. Look forward to seeing you in person at KubeCon. Take care.
All right. Thank you. Thanks for having me on Cube FM, Bart. Really, really enjoyed it. Thank you for all the great, insightful questions and the opportunity.
Our pleasure. Take care. Cheers.
Cheers.